class is going to be a 006 demo class on data structure and algorithm. The goal of today's course, the goal of the next hour really is one, to go over some of the contents that you may encounter in the 006 demo class. Two, get a feel of what the data structure class look like. We'll do some projects together. Pretty short ones since we only have 1 hour together, but we'll do some projects together. And three, also take a look at some of the entire curriculum. All right. If you can open up your camera, that'd be awesome. Since it's in Zoom and it's nicer for me if I can see you guys, but not required. And one last thing before we begin, if you have any questions at any time or any comments or anything, feel free to just unmute and just yell it out or put it in the chat. Yeah. All right, so let's begin. We're actually going to start by taking a look at the curriculum. All right, let me switch to that tab. You have access to this curriculum by just going to the website, but I'll put this in the chat as well. Yeah, you can find it in the website. This should be the most updated version. So, what is the data structure and algorithm curriculum? The course is an in-depth course about two of the fundamental topics in computer science: data structures and algorithms. The course is designed for those with basic knowledge of Java programming and ready to move a step beyond programming language. The course is divided into 2 sub-courses. Each consists of multiple sessions with difficulty gradually increasing. Covers everything you need to know for competitive programming, from basic concepts to practical experience. Yeah, and then most importantly, you'll be able here, if you're able to master all the content in this course, you'll be able to stand on the USACO open contest. Most importantly, this course develops the skill of modeling logical thinking and clears the way towards advanced topics in computer science and artificial intelligence. In essence, you're going to be basically looking through a bunch of different data structures and algorithms and how you can implement them. Some of the topics you'll see in the really beginning, the first session, include binary search, recursion, dynamic programming, linked list, sort, etc. Which you'll see that later on in session 2 and session 3. Some of the topics really repeat. Like you'll see binary search again, recursion again, sort again. Right down here, you'll see like map set, which is covered in the second session. The reason it's repeating is because we basically introduce you to some topic, right? Now we'll go through some problems with them. And then later on, there's going to be a problem that's going to be associated with the same topic, but just more difficult. It's more challenging, more difficult to implement, etc. That's a quick overview of the curriculum. Any questions about the course itself, like what it's about? Now, there is one thing I want to mention. The course is in Java. I know if you're familiar with Python and not Java, yeah, I would recommend either signing up for the Java course and just get some understanding of Java first before signing up for this class. All right, the entire course is going to be in Java. Today, we're going to start out with an introduction of what the data structure algorithm is, and then we're going to do some projects with binary search. Data structure and algorithms. Installation is something we won't be covering in the demo class, but in the actual course, you're going to have to download a few packages. I'll explain that towards the end of the class. So, what is data structures? A data structure is a data organization, management, and storage format that enables efficient access and modification. Consists of the collection of data values, relationships among them, and a functional operation that can be applied to the data. So, to put it simply, it is a way to store information in which you can process them efficiently, right? That enables efficient access and modification. Some examples of some common data structures. If you've taken Java, you've probably seen a few of them. Array lists, you've definitely seen. We'll talk about it as well in the course. And there's linked lists, and then tree, queue, stack, heap, map. It's a bunch of them. It's a lot of them. All right. Now, so that's one major part of the course, like data structures and algorithm. What is algorithm then? An algorithm is a specific procedure for solving a well-defined computational problem. The development and analysis of algorithm is fundamental to all aspects of computer science, which you can see like in artificial intelligence, operating systems, security, and whatnot. Algorithm, in essence, then, is basically a step-by-step procedure to solve some computational problem. Example is later on you'll see a binary search, right? How can you use binary search to find a number in an array, find a number in a sorted array? Which is a common, well-defined computational problem, and then you apply the specific procedure to solve it. Some common algorithms include binary search, quicksort, depth first search. You'll see a lot more of them later on as well. A bunch of them. Wow. How do these two connect then? How does data structures connect to algorithms? The relationship of data structure and algorithm is that the functions or operation of a data structure utilizes algorithms, while an algorithm will act on specific data structures to manipulate the data efficiently. An example is, let's see, an example is like array lists, right? What makes an array list stand out is that you can immediately jump to the end of an index, and then you can use this property to essentially do binary search. Other ones like linked lists, maps, queues, whatever. Each data structure have their own properties, or its own thing that makes it special, and then algorithm really just uses that to manipulate the data efficiently. Data structure algorithms are two of the fundamental topics in computer science. All right, so that's an introduction to data structure and algorithm. These are really definitions, so it's just meant to be introduction. The majority of the course is going to be project-based, meaning it's going to be mostly you working on project and code. Lecture, there isn't too much lecture, really. It's in the first unit, really, we introduce you to some topic information, like those definitions. And in this case, complexity analysis. Right after this, we'll jump straight into binary search. So what is complexity analysis? Well, complexity analysis is really a way to see how efficient an algorithm is. You know, some algorithms are going to be more efficient than other ones. You'll see some examples soon you'll see some examples in the next slide. So an example is time complexity. Time complexity describes the amount of time a function takes, which in terms of the amount of input to the algorithm, while space complexity describes the amount of memory an algorithm takes in terms of the amount of input. Cool example is, a pretty simple example is right here, right? So what is the time complexity of this linear search algorithm? In this algorithm, you're given a number of arrays and you just sort through it and you're trying to find a number, right? The function is pretty simple. You're given a number of array, you're given a target value, and then you want to try to find out where is that target value located in that number. And then by looking at this, you can really quickly, in this case, a pretty simple example, that's it, but you can tell what is the time complexity of this algorithm, which is in big O notation, which is the way you would write out time complexity of space, write out complexities, is ON, meaning the for loop contains n units of operations, while the space complexity is O1, since it's constant space, no extra space is used. You can see why this is ON just by just thinking about what is the purpose of this operation, right? Take a look at the function on the right-hand side. You're given a number of, you're given an array of nums, and you're given a target value, right? Now, what happens? You loop through that entire array, and then the moment that array the moment you see a number in that array that matches the target, you return the index, the position of that number. So, in the worst case scenario, right? The worst case scenario, you have to loop through the entire array once. That is that is the worst case. So in this, that's basically what you're trying to do when you find the time complexity. What is the worst case scenario? What is the longest time it'll take for the program to finish? Space complexity similar, right? How much space will this function take? In this case, constant space, because you are not going to be creating any lists, not creating any variables, nothing. Hence, a space of O1. Now, time complexity and space complexity, this is, by the way, just me talking about the course again. It's going to come into play over and over again when we look at different algorithms, different data structures. So it's important to just get a general idea of what it really is and how it works, but you don't have to go too deep into it. You'll see what I mean in the later example we work on binary search. Right. The idea, really, the main idea right now we want to know is really one, what they are, and two, you can, by looking at them, you can tell whether or not a function really runs faster or runs more efficiently. Right. Whereas in linear search, it has a time complexity of O(n). In the binary search example we'll see in just a bit, it has a time complexity of O log n, which is a lot faster. All right, so that's enough of lecture on data structures and definitions and time complexity and whatnot. Now let's do a quick activity. Any volunteers? This is going to be a one-on-one interaction.
I can, yeah.
All right, great. So this is a pretty simple game. There is a number. I'm going to think of some number between 0 and 1,000. All right,
Okay.
and I want you to guess what that number is. Now, the way you guess is you pick any number you want to pick. I'll tell you if the number you picked is higher or lower than the number I'm thinking of, and then you just keep going until you figure out what the number is.
Okay.
Got it? All right. You start.
With a guess?
Yeah, so I'm gonna pick a number between 0 and 1,000. You want to try to
Yeah.
guess my number in the least number of possibilities.
Okay. Then I guess 500.
Great. 500. So the number I'm thinking of is lower than that.
Then I guess 250.
Higher.
Then I guess 350.
Lower.
Then I guess 300.
Higher.
Then I guess 325.
Higher.
Then I guess 337.
Higher.
Then I guess 345.
That's it. That's the number.
Nice.
There you go. So walk me through your thought process here. What made you choose these numbers?
Basically, I tried to pick the middle of whatever like range I had. So in the beginning, I had like 0 to 1,000. So I picked the middle of that. So that way, I have like if it was lower, then I have like the lowest amount, like the smallest chunk lower that I could have. If it was higher, then I'd have the smallest chunk higher that I could have to then shrink my range by each time.
Perfect. So
which is binary search, I believe. Yeah.
Exactly. That's exactly the thinking behind binary search. Every iteration, for every guess you make, you essentially eliminate half of all possibilities, right? So if you instead use linear search, which is the example we took earlier, where you start from the really beginning, in the worst case, you're gonna have to make 1,000 guesses. By using binary search, you can see that even in the worst case possible, which would be some number like where you split all the way to the end that you can find, it will still be a lot faster than linear search. All right, so this is basically the part that we're going to be working on today, and make sure you understand this idea behind binary search. The idea is for every guess you make, you eliminate half of all possibilities, so that you limit your range, you limit your possible values to half of the previous iterations. You just keep doing that until you locate what that right number is. Any questions about this before we move on? Great. All right. So let's get started with the project then. Let me switch my slides. And search. Right. Now, another thing I want to talk about binary search is time complexities. The time complexity of binary search I mentioned a bit earlier is O log n. And why is it O log n? So again, to think of time complexity, you want to think of what is the worst case scenario, like how long will it take for the worst case. So let's assume we have an array. Again, this is all going to be it's a sorted array. It only works on a sorted array, really. The length of the array is n. So in the first iteration, we pick a number right in the middle. And then so after the first iteration, we eliminate half of all numbers, right? So after the first iteration, we narrow our search to n over 2. There's only the possible values are arranged we have n over 2 numbers left in which the possible value can be there. We keep going. We keep dividing 2 and 2 and 2. And we keep going until we reach an n of 2. At the kth iteration, in this case, the worst case scenario, right? At the kth iteration, when there's only one value left, since we have kept splitting and splitting and splitting, we have n over 2 to the k power. And do a bit of math, you'll see that n over 2 to the k, you set n over 2 to the k equal to 1, since this is the worst case scenario. So at kth iteration, there's only 1 left. So you know this is going to be true. Do a bit of math, take the log of both sides. You'll get that k equals log base 2 of n. Hence, the time complexity is just O log n. And then if you know a bit of log, you'll know that this is a lot faster than O n. Right. Now, the 2 is removed simply because we're in big O notation. Like, we don't care about constant values. So you can just ignore that when we're writing the time complexity. Any questions about this as well? Perfect. Now, let us continue. I'm going to need you to open up any kind of Java editor on your side. Usually what would happen is in the first class, you would download, we would go through a few installation process where you would download Jupyter Notebook. Most of our code, actually all of our programming is going to, in course, in the curriculum, is going to be done through Jupyter Notebook. And the reason is we can, in the Jupyter Notebooks, there are, let's see, this empty, it's not empty. In the Jupyter Notebook, we have templates. I mean, what I mean by templates is, you know, for one, you can, there's an area you can code, you can test it, and we also have validators installed. However, since this is a demo class, and then the installation take a while, so instead of using Jupyter Notebook, I'm going to need you to open up any Java editor on your side. Oracle, I mean, Eclipse, Visual Code Studio, VS Code Studio, I think, any will work. Even if you don't have any of these, online Java editor, that's fine too. Just like search up online Java editor, boom, like the first one will work. All right. Yeah, open that up and then we'll continue. I'm going to wait for like 1 minute. All right, so we'll continue at 8:21. All right, I'm going to get started. If you haven't been able to open up some Java editor yet, that's fine. When we start working on the code, you can keep on, you can finish up the process then. All right. Our first project is going to be just simply binary search. Given a sorted array of integers called nums, array of integers nums sorted in ascending order, by the way, so like 1, 2, 5, 6, 7, 9, 10. And they also given an integer target. We want you to write a function that searches this number target in the array nums. If target exists, return the index. Otherwise, return -1. An example is right here. So usually, you know, you would have access to this notebook and you would see all this example on your screen. However, you don't have it right now, so just click on, you can just look at mine. You have a number, you have this, given this array, and then you want to find out what is the index position of some target. In this case, we want to look for number 9, look for 9. And you can see that the array is 0, 1, 2, 3, 4, index 4. So the function returns 4. Now, obviously, you can loop through the array linearly, right? But our goal is to binary search. Because if you do linearly, it's slow. What if it's a really big array? And that's the goal. Now, if we look down here, if the target value is not in the array, which can happen, we return -1. Any questions about what the code is supposed to do? Now, a few of you probably, all right, good. Now, a few of you probably know how to code binary search, I'm guessing, maybe, maybe not, doesn't matter. How the course will usually function is whenever you reach a new topic and a new project, what will happen is I'm going to ask you to only look at my screen and don't copy anything down while I'm explaining anything or coding. And then while you're looking at my screen, I want you to I'm going to be coding the entire thing line by line while explaining what's going on. And the goal is, hopefully by the end of my explanation, you'll basically get a general idea of what code, what line is supposed to go where and what you're supposed to do. And then once we've gone over that, or while I'm doing that, I want you to just try to think about what's going on, try to understand what's going on. And once we've gone over that, I'm going to switch my tab to something else so you don't see my code. And I want you to try to recreate what I've just coded on my screen on your own. Does that make sense? Does that process make sense? That's basically the general approach we're going to be taking for each code. Great. All right. So I'm going to get started with the coding, with the code. Again, don't write out anything. Just look just look at my screen and try to understand it. All right. Binary search. Also, another thing I want to mention before I talk about binary search. On your side, you may have to write your own main methods or write your own functions. Right? You'll probably need to write a main method, because it's not there's no validator on your side. You're starting from scratch. Just letting you know. All right. So, how binary search works is main idea is given this array of numbers. Right, let's use this as an example again. You first, just like how I was saying Carter did it earlier, right? Was that example? Look at the midpoint. If the value associated at the middle index, in this case actually will be 3, is bigger than the target value, then if it's bigger than target, in this case it's smaller than target value. So if it's smaller than the target value, we narrow our possible range to all the numbers above the middle point. And then we do that again. Then we find the new middle point, which in this case will be 5. If it's still smaller than 9, which it is, we narrow our search to the range of values above that middle point. And we keep going until we either find that number or we run out of number to search through. But in that case, we return -1. All right. Let me zoom in here a bit. So you'll see that actually all binary search cases, you're going to start with initializing 2 variables. A starting variable and n equals nums.net. Right. I'm going to start with a start and end variable to these 2 variables keep track of these 2 variables keep track of what is the range of the values you're looking at. So in a iteration, you're going to move them a bit closer to the midpoint, really. While start +1 is smaller than end, and the rest is basically going through the motion of the binary search, in which case we need to find the midpoint. All right. Now let me explain these 2 lines really quickly. The while start +1 smaller than end, what this is doing is you're going to be looping through the binary search process over and over and over again until you have looped the entire thing. In each iteration, you'll see in just a bit what I mean by this is in each iteration, you're going to move your starting point and your ending point a bit closer to each other. And then theoretically speaking, if the target value is in the array, your 2 numbers will never meet because you're going to find that array, you find that number before they meet. But if they meet and they cross over each other, in this case, you see start +1 is smaller than end, which shouldn't, if at any point the starting point is greater than the ending point, you know that you've looped through the entire array, you've looked at everything, and you still haven't found the number. And in that case, you can at the end add a return -1. Right? Now, while you're looping, you need to find a midpoint, which is I discussed earlier. This is the same as a midpoint formula, like you do start plus n divided by 2. If I'll do the math really quickly, it's the exact same thing. The reason we do this is because we want to prevent overflow. That's it. All right. If you have really big numbers, if you don't know, if you have really big numbers and integers, it loops to the other end and becomes a negative number instead. And so this is just a way to avoid that. So if nums mid equals target, return mid. Pretty straightforward. If it's the moment you find a number, if the moment you find the index on the number, if that number is the target value, you return the index. All right. Otherwise, if that's not the case, you want to check whether or not this number is smaller than the target value or bigger. We're going to first check if it's smaller. If the midpoint is smaller than target value, we set start equals to mid. All right. Now think about what this means. If the target value is smaller than the midpoint, that means the midpoint you're looking at is to the left of the target value. So if the midpoint they're looking at is to the left of the target value, which is let's say right here, then what you can do is you can eliminate everything to the left of the midpoint. And what you do is you just set start, which is initially at 0, move it up to midpoint. And then you're left with half of the remaining array. And then you know that the target value is going to be in this remaining array up here. All right. And then we do the similar thing with else. In this case, what else means is just if the midpoint is bigger than the target, right? If it's bigger, you set n equal to mid. Same logic. You can try to map it out in your head. But if it is bigger than, then you can move the n to the midpoint, and then we eliminate half of our possibilities. And that's it. Now you can add 2 more lines here, where to like do like a catch-all. Let me one sec. Am I missing any? No. Like if num start equals target, return start. If nums n equals target, return n. You can add these 2 lines basically for the sake of, okay, what if we kind of missed the 2 numbers and they're at the start or the end index. You don't need them. I mean, if I delete them, you run it. I mean, I need to load it in 1 second. It's still going to work. But if you add them in, you'll see these 2 lines are actually going to be pretty helpful when we do the next part of the code. But we'll talk about it in a bit. All right. And that is really binary search. Basic 3 parts, basically. First, initializing 2 variables, the start and end. Second, finding a midpoint. Third, changing that midpoint. Or actually changing the end or the start point to the midpoint. Any questions on how binary search works or how this code works in particular? All right, great. Now, if you have any question anytime, message me in the chat or just say it out loud. That's fine. Now, what I want you to do now is on your own Jupyter notebook. I'm going to move my screen up here so you don't see the code. On your own Jupyter notebook, I want to code your own binary search function and then test it. All right. Code your own binary search function. Yeah, now, you don't have a validator, so you're gonna have to manually input some arrays, but just test it, see if it works. And yeah, let's spend like let's say 9 minutes on this. Like we can meet at 8:40. We'll regroup at 8:40. If you finished, send me a message. Let me know if you finished. Otherwise, get started. All right, 1 minute left before we can talk about what our progress is. Again, keep in mind, if you're done, let me know. All right. All right. Um, so who finished? Anyone? It's fine if you haven't, by the way. All right. Who wants to spend some more time on this, by the way? Or who would, if you prefer for me to like go over it again really quickly, fine with me as well.
I didn't finish, but I'm fine continuing.
All right.
Yeah, I understand it. So.
All right. Sounds good. So here's what we're gonna do then. All right. If everyone found this, um, this is I'm going to introduce a quick extension of the binary search one. So you're gonna need to understand how this works for the next anti-word. It's a simple modification that I want you to take a look at. All right. So this project is called first position of target. Again, you're given a array of integers called nums, which is sorted in ascending order, and you're also given an integer called target. Goal then is to write a function to find the first index of target in nums. If target exists, you return its index, otherwise you return -1. An example would be right here. Let's take a look at the second example. Given an array 1, 2, 3, 3, 4, 5, 10, you're given the target 3, and then you want to find the target value 3. Now you'll see that 3 is duplicated here. When we do if we just use our old the binary search function we just used to try to calculate try to find the index, you'll know that the function is going to return this one instead. It's going to return 0, 1, 2, 3. It's going to return 3. However, the actual output is going to be 2, because that is going to be the first position in which this target value shows up. And so how do we modify our binary search algorithm to make it so that the first position shows up? Right, that's the question. So I'm going to quickly explain how it works. Now, the code itself is actually it's a really simple change. I think it's the part with wrapping around your head. That's the more confusing part. So I can really copy a lot of what I have here. Actually, I can copy everything I have here, and then move it over to the other formula. Since it's still binary search, right? It's almost the exact same thing. Now, what makes it different is in first position, you'll see that in the binary search formula, you have this if statement right here, where the moment you find the midpoint, you return it. We don't want to do that. If we find the midpoint, that doesn't mean we found the first position. If we found a midpoint in which it is a target value, that doesn't mean it's the first position in which that target value shows up. And so we shouldn't return it. In fact, what's interesting here, you'll notice that if the midpoint is the target value, then you'll know that the first position of that target value has to be either the value you're looking at or some value to the left of it, right? That makes sense, right? If the value at the midpoint index is equal to the target value, you know that the first position of the target value is going to have to be either to the left of the midpoint or is that midpoint. And so by using that idea, we can delete this line right here. And then just modify this by just adding a, let's see, I simply adding equal sign here, right? No, we don't need to do anything. This works. Yeah, that's right. Boom. You remove the midpoint and that's it. And you can see why this works. So this part is still the same. If the midpoint is smaller than the target, which means the midpoint is to the left of the target, midpoint, left of the target value, you move start up to the midpoint, right? Now, on the other case, if you found the midpoint and the target value is here, you set n equal to mid, that's the same. But if the midpoint is the target value, you know that the first position either is this point right here or some point before it. And if that's the case, you can move your n still equal to, you can still move your n equal to midpoint because you know that the target value is going to be in the first part of the array. And now you'll just keep doing this and doing this and doing this until you reach to a point where you only have two values left. The start, where in this case, you get to a point where the start plus one is equal to end, right? It's going to be two adjacent values. And then at that point, either the starting index has to equal to the target or the ending index has to equal to the target. If neither is equal to the target value, you know that none of the values are going to be equal to the target value and you return negative one. And that's it. All right. Pretty simple modification of the code. Yeah. If it's confusing in this sense, that's perfectly fine. What I recommend in terms of trying to understand the code is just manually by hand try to understand what it's doing. I just like pick some like examples like this one, and just go through this process by hand. You'll see it. You'll see it all works out by the end. All right. So here's what I'm going to do. Since this is pretty simple, we'll just work on this for like, let's say 3 minutes. I'm going to leave the previous binary search code up. So this is going to be the first one, right? Not the first position one. So if you haven't finished this one, feel free to just copy it down. And then if you have finished it, work on the other project. We'll regroup at 8:50 or 8:49. So finish first position of target. All right. Any questions? Here's the code again. If you want to take a screenshot or anything, go for it. Here's the code. Excuse me. Here's the code. Yeah, there is one more project left in the binary search one. We're not going to have enough time to finish this one because this one is slightly or a lot more complicated than the previous two. But I'm going to introduce it. And then you can think of this as some exercise for home. All right. Again, binary search. You're given an array nums. In this case, however, the array is rotated. So in an original ascending array, you may have the value 0, 1, 4, 5, 6, 7, 0, 1, 2, 4, 5, 6, 7. But then it's randomly it's rotated at some random index like this. It becomes 4, 5, 6, 7, 0, 1, 2. And then the goal is still the same. You're given this rotated sorted array. You're given some target value. You want to find out where is this target value. Oh, geez. You want to find out where is this target value in the sorted array. So yeah, that's a goal. It's still binary search. And then we still want to use the process of binary search. There are a lot of ways of approaching this problem. Right? One way of approaching this problem is you can find that pivot point. And once you find that pivot point, you can like loop through it and then find the original array that's unrotated, and then linear search and do binary search again on it. That's fine. But you notice that if you do that, it's gonna be a lot more. It's gonna take a lot more time. Time complexity is anyway higher. So that's a problem. Now, how do we do this? The thing is to recognize. The goal is then to recognize if you find a midpoint and then you find your target value. You want to figure out which part of the array is your midpoint and your target value located on. So let's take a look at the first example. If the target value is 0, right, you can think of splitting this array into two parts. The parts that's rotated and the parts that wasn't rotated just got pushed back. If the target value is smaller, actually let's do this quick thinking activity. How would you tell if the target value is on which part of the array? What is something simple you can do to immediately tell if the target value is on the first part or the second part of the array? The part that's unrotated and the part that's rotated, or the part that was in the first part originally?
You could look at the first number of the array.
First number, so this one?
Yeah, compare it to the target value.
Exactly. And then so what kind of like if statement would you do in this case?
If nums 0 is less than less than or equal to target value, then you know that it's in the first half of the array, the rotated part. Like, you know, the target value is in the rotated part. And if it is greater than the target value, you know that the target value is in the end of the array, the non-rotated part.
Yeah, I think you mix it up. Did you? I think once you write it down, it will be more clear. But it's basically that logic.
Yeah.
Yeah, it's basically that logic.
Right.
You compare the first index to the target value, and then just by doing that, you'll be able to tell which part of the array it's where is it in the array. And it should make sense logically because you're rotating the array, right? You rotate it. So everything after the first index is going to get bigger and then suddenly become smaller. And everything smaller than that, it's going to be, smaller than the first index because it was in ascending order. And then once you find out where is that, where your midpoint and where your target value is located on, actually no, the moment you find out where your target value is located on, the problem becomes a lot simpler. You just run normal binary search on it. You just run normal binary search on once you find out, what it is. And so okay, we have 1 sec. We have 5 minutes. So instead of just coding it all out, I'm just going to show the solution and then just walk through it instead. Right? Usually, again, I would code it out one line at a line, line by line, but for reason of time, I'm just going to show the code. Here it is. In the beginning, it starts out the same. Right? You start out with start equals 0, end equals 0. sorry, n equals num.length minus 1. This is your initial index and the ending index. Now, these are still the same. Find the midpoint, whatever. And it's the moment you find the midpoint, the moment you see that the midpoint is a target, you return the midpoint. And here's where that whole finding out which part of the array comes in. If the midpoint is greater than the first index, and your target value is greater than the first index, so in this case, if you know that both the midpoint and the target value is going to be on the first part of the array, right? If the midpoint and the target value is on the first part of the array, you run normal binary search on it. And then you just like, since you know it's on the first part of the array, they're going to be compared. You can compare them regularly, right? So then if the midpoint is smaller than the target, you set start to mid. Otherwise, you set end to mid. Another case is if you know that the midpoint is smaller than nums or target smaller than the nums as the first index, you again run normal binary search on it. If midpoint is smaller than target, set start equal to mid. Otherwise, n equal to mid. You notice that what this really means is if you know the midpoint and target value are on the same part of the array, if both of them are on the same part, either the first or second, normal binary search. Otherwise, if they're on different parts of the array, it's still a simple solution. You just move your start or your end equal to mid. No matter what the case is, you're basically still moving your start or your end closer to the target value. Let's take a look at what this says right here. If the midpoint is greater than the first index, if the midpoint is greater than the first index, you know that the midpoint is in the first half. And then if target is more than the first index, it's in the second half. If the target value is in the second half, midpoint is the first half, then you can set your start equal to mid. You're pushing it this way. All right. And otherwise, vice versa. And then finally, this is still the same as the first position or not. Yeah, you return -1. Right, any questions? Now, all of this are taken out of the first unit of the data structure curriculum. So if you do decide to sign up for the curriculum, you're going to be able to see this project again. All right. Now, last few things before we continue, we wrap up the class. Let's see. So there's this. Right, so this is a curriculum. Let me see. I don't need to show that again. I showed that before. If you're interested in signing up for the class, I should have done that in the beginning. If you're interested in signing up for the course, registering for it, you can do so at the link I just sent out in the chat. It's pretty simple to use. You just click the class you are interested in teaching, and then you just schedule your class. I believe there's I'm not sure if it's here, but I believe there's an option to suggest a time as well if none of these time work for you. But yeah, just play around with the page. Yeah, if you're interested in signing up for the course, sign up for this class. I highly recommend it. There are some really interesting topics and really interesting problems as well that's discussed later on. All right. Otherwise, that basically wraps up the demo class. The class technically doesn't end at 9, so I'm gonna stay here. And then if you have any questions, let me know. Or if you want to work on this code a bit more and just write it down or take a screenshot, feel free to do so. I'm still gonna leave the Zoom up for a while.